Today's lesson is about using what are called the exponential growth and decay formulas to solve at 80% accuracy or higher. So we're actually looking at exponential growth and exponential decay like in the real world. So things like when you buy a car, how they depreciate really fast. So things that decrease at a really fast rate, like exponential decay, or things that increase at a fast rate, like an investment, something like that, exponential growth. So there's different formulas for decay and growth, but they are really similar, so we'll explore that. You need to make sure that you're using the correct formula. And you get to use your notes on your entrance ticket, so it's going to be an entrance ticket tomorrow, not an exit ticket. You get to use your notes on it, so I'm not going to provide the formulas. All right. I'm still thinking about whether or not I'll provide it for the topic 5 test. Normally, we do not provide it. So just keep that in mind. Make sure you're taking good notes. And then part of that is being able to identify initial amount, growth rate, and a time frame when you're given a description. So like, can you comprehend what the problem is saying and identify those 3 things? All right, if you can, then you'll be successful. Because it's a really short and sweet lesson. It's just plugging things into a formula, using your calculator, and writing the answer. So I'm recording right now, and I'll put it here in the slides like I always do, but there's some other examples if you want to check those out too. The practice is only 8 problems, so it's not evens or odds, all right? It's the whole thing. So last hour, a lot of kids finished it, and they finished early. So all problems are assigned on that paper. I will check it tomorrow while you take your entrance ticket. And if you are not here tomorrow or you don't have it finished by the time you walk in when I check it, then you need to upload it yourself in Schoology. Now, yesterday you guys took your first assessment of the semester. And I know that because it's the beginning of the semester, there's only 1 assessment grade in there. If you missed like 1 problem on your exit ticket yesterday, then it brought you down to like a 66%. And that's just how it is, all right? It's the beginning of the semester. So if you do not want to wait until the topic 5 test to get those points back, you can do test corrections. And this has been a thing since last semester. That's what you could have done last semester too. I said it a bunch of times. And it's the same process. So you don't necessarily have to come to tutoring to do these test corrections. You can do them at home on your own lined paper. Just, write the name of the test, say which one you got wrong, why you got it wrong, like maybe you did a calculator error or something, and then rework the problem and pick your new answer. Or if you can't show work, write a sentence to explain your answer. If you only provide an answer, and I still have kids that do this, they'll just send me a paper that says 1 is A. All right, you will not get credit for that. I have to know that you took time and aren't just like guessing for a new answer. Once you do that, you can take pictures of it and email it to me. My email is right there. So, look at the slides if you need more help later. Again, tomorrow it's an entrance ticket, so we'll take it right at the beginning of class. It's a short and easy lesson, so we'll just keep trudging forward so that we have more time to review at the end. So questions? All right, so we are taking notes on this paper, so have it in front of you. And first, we're going to talk about exponential growth. So I said that growth and decay have different formulas. And the problem won't necessarily say use the exponential growth function. All right, you have to figure out if whatever is going on in that situation is increasing or decreasing. All right, so is growth increasing or decreasing? Increasing. So anything that is increasing, that is growing, you're going to use this formula. All right, it's y equals a parentheses 1 plus r close parentheses to the t power. All right, and I'll explain what each part means. But this is growth, because when we were talking about it the past 2 days, remember how we said that if the number attached to the exponent is bigger than 1, that it's growth? Well, if I add 1 to basically anything, it'll be bigger than 1. So that's why this is growth. A will stand for your initial amount. So fill that in. Initial amount. R will stand for your growth rate, and in parentheses or somewhere that you can write this down, put as a decimal. You can write it somewhere else. All right, and then T will be time. So those are the 3 things you need to be able to identify in whatever situation it is in order to use that formula. So number 1, we have the original value of an investment is $1,400, and the value increases by 9% each year. Use an exponential growth function to find the value of the investment after 25 years. So the keyword there is increasing. All right, even if it didn't say use an exponential growth function, you should know that increasing means this formula. So we need to identify those 3 things. What is my initial amount in this problem? 1,400. 1,400. So your initial amount is the amount that you start with. So in this one, it is $1,400. What is the growth rate? The growth rate is what it increases by, so 9%. However, we need to write it as a decimal. You cannot just plug in 9. All right, so do you guys know how to write 9% as a decimal? 0.09 is correct. If you're ever unsure, just take whatever percent it is. So this is how to convert percents to decimals, and divide it by 100%. All right, you get 0.09. That will be the growth rate, not just 9. All right, you can also think of it like money. All right, 9 cents, because all percents are out of 100. 9 cents would look like this. And then lastly, what's the T going to be? 25. So T is time. So questions about everything we've identified. All right, now plug it into your given formula. I think it'd be good practice to write the formula every time so that you have it memorized. But plug it in. A we said is 1,400. And then it's always 1 plus the growth rate as a decimal, which this time is 0.09, to the 25th power. Now we can simplify this like step by step, but we could also kind of just make our lives easier since we all have calculator access, whether it's handheld or on your Chromebook. So you could just kind of save yourself the trouble and let the calculator do order of operations for you. But even if like your calculator doesn't let you put multiple things in it at once, you should know that you would do parentheses first, and then exponents, then multiplication, right? So everything to the right side of the equal sign can be entered in the calculator exactly how it looks. So 1400 parentheses 1 plus 0.09 to the 25th power. If you are getting something other than this decimal, then you need to let me know. All right. Nothing worse than the calculator messing it up for you. Now, how do I know how much to round this number? Someone did say it? Because it's money, right? So how much does money, or how many decimal spots does money go to? 2. So remember your rounding rules. I always have to review them. All right, when you need to round to 2 decimal spots, or whatever number you need to round to, you need to look at the number directly to the right of it. So if that number is from 0 to 4, then the number that you're rounding to stays the same. If it's from 5 through 9, then you round up. All right, so is it going to be, let me write the first part. So $12,072. And is it going to be 31 cents or 32 cents? 31 cents. All right. This 2 is between 0 and 4, so it should stay the same. Questions? All right. So let's do an example that isn't necessarily money. All right, but this is how much that investment is worth after 25 years. So originally they put in $1,400 and they just kind of let it grow till about $12,000. So a good investment, even though that 25 years is a long time. All right, now let's look at one that isn't necessarily about money, and then I'll have you try one yourself. So look at number 3. The number of student athletes at a local high school is 300 and is increasing at a rate of 8% per year. Use an exponential function to find the number of student athletes after 5 years. All right, so since it is increasing, you should know to use the formula at the top of your page. I'll write it over here. All right, but it's the one where it's 1 plus r to the t power, and then that a over here. So A stands for what? Initial amount, and what is my initial amount in this one? 300. What is my rate? Good, and then just make sure we don't put 8 right here, do we? 8% as a decimal is 0.08. And then the t for time, what's the time frame? 5 years. So I know there's probably not a lot of work that you have to show, but on your practice, at least like do this. All right, I want to see that you're like writing the formula, that you're pulling out the important information. It's good practice. All right, then plug it in your formula. So 300 parentheses 1 plus the growth rate and to the t power, so 5. Don't make your life harder, put it into your calculator. All right, and if you're getting anything other than this number on your screen, then let me know. All right, but we also need to pay attention to how we write the answer. So are we talking about money? No, we're talking about people. Can I have a decimal of a person? No. No. So what would my final answer be? So good rounding, but since this is like a real world situation, the formula doesn't fully support that there's 441 students. All right, it's saying that at most, basically, there's 440 students. Does that make sense? I know that goes against like normal rounding rules, but you have to think about it like in the real world. All right, so at most, the students would be 440. Right, because we can't have a decimal of a student, and the data just doesn't support us rounding up. 440 at least. Does that make sense? Any questions? All right, so then I'm gonna have you guys try number 2. So number 2 will be the U try. So the cost of tuition at a college is $12,000 and it's increasing at a rate of 6% each year. Use an exponential function to find the tuition cost after 4 years. So even though it doesn't say exponential growth function, make sure you use the one for exponential growth, which is the only one I've shown you so far. All right. What did you put for your initial amount? Good. And what did you put for the rate? Good. In your formula, it should be 0.06. And the t is 4. So plug it into your formula. It should look like this, plugged in. So 12,000 parentheses 1 plus 0.06 to the t power. All right, just a side note, I'm sure you guys would probably figure it out on your own, but sometimes on a test, like it might just have you model it. Sometimes they just like add these two together already. So sometimes on a test, they might just put in the parentheses 1.06. All right, so if you imply that it's already been added for you. All right, but what did you guys get as your final answer?
Y equals 15,000.
15,149.72. And we get something different. All right, so this is the correct answer. At least that's what it says on my paper. Let me put it in the calculator just to make sure, because there are mistakes sometimes on my paper. So let me put this in the calculator. $12,000 1 plus 0.06 to the 4th power. All right, so that is correct. Any questions? If you got something different, just double check. Did you accidentally leave off the 0? Did you accidentally make the decimal 0.6. All right, because that would change it. So make sure it looks just like that in your calculator. Any questions? All right, so let's look at decay. So all we talked about so far is growth. Decay is really similar, but it has a slightly different formula. All right, so the formula for decay is going to be y equals a parentheses 1 minus r close parentheses to the t power. All right, so what is the only difference from this formula to the other formula? It's now subtracting r. And doesn't that make sense? Because yesterday we talked about how if the number attached to the exponent is smaller than 1, that it's decay. So that's what I would remember for the test. All right. If it's decay, 1 minus whatever number would always be smaller than 1. So decay, you use this formula whenever stuff is decreasing over time. So it might not say use this exponential decay formula, but it might say that something is decreasing. It might say that something depreciates. It might say that something loses value. So any other synonym for decreasing, use this formula where it's minus. All right, but all the letters stand for the same thing. You will have an initial amount. R will be decay rate, not necessarily growth rate, but decay rate. And it should still be a decimal. And T will be for time. Questions at all? All right, so we'll do one together probably, and then you'll do one on your own. So first, we have the population of a town is decreasing at a rate of 1% per year. In 2000, so like the year 2000, there were 1,300 people. Use an exponential function to find the population in 2008. So identify your 3 variables. All right, what's the A going to be?
1,300.
Good, 1,300. But no one said 2,000, but like in the past, people have said that. So just make sure you're interpreting it the right way. What's the decay rate? 0.01. And what is the T? 8. And how do you know that? It doesn't say 8 anywhere. How do you figure that out?
Because between 2000 and 2008 is 8 years.
Good. All right, so use your critical thinking skills. If we're looking at a range from 2000 to 2008, we'll subtract the 2. And you get a total of 8 years for the time frame. All right, so then we plug in 8 for the T. All right, remember the formula is slightly different this time. It's 1 minus now. And then we're just plugging into the formula and solving. So 1 minus 0.01 in parentheses to the 8th power, and then don't forget the initial amount over here. All right, plug it into your calculator. All right, should look like that on your screen, whatever calculator you're using. If not, let us know. And how would I write my final answer? Good. All right, so since we're talking about people, all right, we're not gonna put a decimal in there. The data doesn't really support 1,200 people. So we'll just like round it to the whole number that is there. All right, so just round it to whatever whole number is there. But does that make sense? Any questions? All right, I'm gonna have you guys try number 8, and then depending on how that goes, might call it a day after that. But try number 8. All right, so the value of a car is 18,000 and depreciating at a rate of 12% per year. Use an exponential function to find the value of the car after 10 years. All right, so what is my initial amount? 18,000. Good. My rate? 0.12. Good. And I didn't give you any warning about that. Just kind of wanted to see if you guys knew that 12% written as a decimal is 0.12. All right. And if you're ever not sure, because I always doubt myself during a test, I have to like check things 10 times. 12% divided by 100% gives you 0.12. That's how you convert percents to decimals. Questions about that? And then what is T? It is 10. Plug it into your formula. Make sure you're using the correct formula since it is decreasing. Right? You don't want to end up with an answer that is greater than the initial amount. So plug it in, 18,000, parentheses, 1 minus 0.12 to the 10th power. What did you get in your calculator? 5,013 point what? All right, let me double check. That sounds like what we got last hour, but again, just like to double check. All right, good, and we even rounded it correctly. So if you got something different, make sure you fix it. Here's what it should look like in your calculator screen. Any questions? All right, so I'm going to give you the rest of the time to practice, which is honestly a ton of time. It's probably too much time. So practice, make sure you show all your work on your practice sheet and check your answers as you go.